In this film, you will witness the creation of the largest suspension bridge ever built in China, a structure so vast and so ambitious that it redefines what modern engineering can achieve. We will guide you through every stage of its construction, from the first cables to the final roadway, revealing the techniques, challenges, and innovations behind this extraordinary masterpiece. If you enjoy this documentary and want to see more films about the world's most impressive engineering projects, feel free to subscribe, leave a like, and activate the notification bell. Your support helps us bring more stories like this to life. China's mountains are among the most inaccessible landscapes on Earth. Deep gorges, steep cliffs, and vast distances shape the land. And it is here that some of the boldest bridges ever built rise into the sky. Suspension bridges, arch bridges, and modern cable-supported structures connect regions that were once isolated. But China is not only building real record-breaking bridges, the country is also developing new concepts and futuristic designs that may shape the bridges of tomorrow. Some of these ideas seem visionary today, yet they could soon become reality. This blend of existing structures and future engineering concepts shows how far China's bridge technology has advanced. And before we reach the largest suspension bridge ever built, we take a look at the impressive structures and visions that paved the way. China does not build bridges merely to cross valleys, it builds them to connect entire regions. In a country shaped by mountains, gorges, and inaccessible terrain, bridges are often the only way to unite people, cities, and economic zones. Over the past decades, China has constructed more bridges than any other nation on Earth. Some are world famous, others lie hidden in remote provinces. Yet all of them share one thing: they demonstrate how far Chinese engineering has already advanced. Many of these structures look futuristic, almost as if they belong to a world of tomorrow. And indeed, some of the designs we see today are early prototypes of a new generation of bridges that will be lighter, stronger, and more efficient than anything built before. This diversity of real masterpieces and visionary concepts forms the backdrop for the world's largest suspension bridge, which we are about to explore. As China continues to grow, the demand for modern infrastructure grows with it. In many regions, there are no flat plains, no easy paths, no natural connections. Instead, mountains, valleys, and deep gorges, obstacles that once separated entire provinces. But this is where China's engineering brilliance begins to shine. Bridges are not built merely to cross obstacles, but to bring people together. Every new connection shortens travel times, strengthens trade, and links remote areas to major economic centers. Many of these bridges look like technological marvels. Some already exist, while others are visions of the future, concepts that show what bridges in the coming decades might look like: lighter, stronger, more energy efficient. This development is no coincidence. It is part of a national strategy to connect the entire country. And this vision leads us step by step toward the largest suspension bridge ever built. The further you travel through China's mountain regions, the clearer it becomes how profoundly bridges have transformed the country. Places that were once isolated can now be reached within minutes. Roads that used to cling dangerously to steep cliffs now run safely across massive structures of steel and concrete. But behind every bridge lies more than engineering. There is a vision, the idea of connecting a nation whose geography is more diverse than almost any other. Each new bridge is another step toward a fully connected China. And while many of these structures are already impressive, engineers are working behind the scenes on even larger projects. Bridges that will be longer, taller, and more resilient than anything built before. Some of these concepts look futuristic, yet they are already in development. All of these advancements lead us to a structure that stands out even among China's megaprojects, the largest suspension bridge in the world. A project that not only breaks records but demonstrates what modern engineering is truly capable of. With every new bridge built anywhere in the world, the knowledge of engineers grows. China has made remarkable progress in recent decades, but it is not the only nation pushing boundaries. The United States, Europe, and Japan also construct structures that demonstrate how diverse and advanced modern bridge engineering has become. Whether in China's deep mountain gorges or across the wide valleys of North America, every bridge serves as a testing ground. New materials, new construction methods, and new safety concepts are being explored globally. Many ideas that seem futuristic today come from an international exchange of knowledge and experience. This global development has created a foundation on which engineers everywhere can build, a foundation that makes bridges possible that are taller, longer, and more resilient than anything imagined before. And it is this combination of worldwide innovation and local engineering skill that now leads us to a structure that stands out even among the greatest projects, the largest suspension bridge ever built. After decades of experimentation, progress, and international collaboration, China faced a new challenge: to build a suspension bridge that would surpass every structure before it. A bridge that would not only cross a valley, but become a symbol of how far modern engineering can reach. The planning began in a region known for its extreme conditions: deep gorges, strong winds, unstable rock formations. A place where many countries would not even attempt to build a bridge. Yet this was exactly where a structure was envisioned that would astonish the world. Engineers from multiple nations analyzed data, simulated loads, and developed new materials that were lighter and stronger than anything used before. The vision was clear: a suspension bridge that would be longer, taller, and more resilient than any other ever built. Minute by minute, it becomes clear: we are approaching a project that not only breaks records, but redefines the limits of what is possible. The construction of the world's largest suspension bridge began with a task so immense that even seasoned engineers hesitated. How do you build foundations in a gorge hundreds of meters deep, with rock walls that are almost impossible to reach? Before steel or cables could even be considered, workers and engineers had to create access to the site. Temporary roads were carved into the cliffs, platforms were anchored at dizzying heights, and the first measurement points were set. Every step was a risk, and at the same time, a victory. Then came the true challenge: erecting the two main towers. Each one had to be strong enough not only to carry the weight of the bridge, but also to withstand the enormous forces of wind, weather, and earthquakes. Meter by meter, the towers rose into the sky until they reached the height of a skyscraper. Meanwhile, teams from different countries worked on the calculations for the main cables, the massive steel lines that would later carry the entire weight of the structure. Every decision had to be perfect, because a single mistake could have had catastrophic consequences. Minute by minute, it becomes clear, building this bridge was not just a technical project, but a race against nature itself. Once the two main towers had reached their full height, one of the most critical steps of the entire project began: installing the main cables. These massive steel lines are the backbone of any suspension bridge. Without them, the entire structure would collapse. But mounting these cables is a challenge of its own. First, thin pilot ropes had to be pulled across the gorge, often using drones, helicopters, or special rockets that created the very first connection between the towers. Stronger and stronger strands were then pulled along these ropes until a massive main cable emerged, capable of carrying hundreds of tons. Layer by layer, thousands of individual wires were bundled, tensioned, and compressed. Every wire had to be perfectly aligned, because even the smallest deviation could compromise the stability of the entire bridge. When the two main cables were finally tensioned, they connected the towers like enormous arcs of steel, ready to carry the roadway and withstand the forces of nature. Minute by minute, it becomes clear, the bridge is taking shape. The impossible is becoming real. With the main cables fully tensioned, the most visible and dramatic phase of the project began: installing the roadway segments. Each segment weighed several hundred tons and had to be positioned with absolute precision, at a height where even the wind could become a threat. Suspended cranes traveling along the main cables lifted the massive steel sections slowly over the gorge. Inch by inch, they were lowered until they locked perfectly into place. A single mistake could have destroyed not only the segment, but the entire construction schedule. High above the abyss, workers connected the elements, tightened bolts, and inspected every joint. From below, it looked as if the bridge was growing in midair, a floating ribbon of steel stretching further across the valley with each new piece. With every segment added, the structure became stronger, and the final shape of the bridge began to emerge. It was no longer just a plan, it was becoming reality. Before the bridge could take its final shape, engineers had to answer a question that determined the fate of the entire project. Which materials are strong enough to support a structure of this scale? The solution was found in a combination of high-strength steel and advanced composite materials. For the main cables, thousands of individual steel wires were used, each one thinner than a pencil, yet together capable of carrying hundreds of tons. These wires were bundled into strands, and the strands were compressed into a single cable stronger than any natural material on Earth. The roadway deck was also far from ordinary steel. It was built from a lightweight but extremely durable steel composite structure designed to absorb wind forces without deforming. Each segment was engineered to move slightly during storms, just enough to dissipate energy, but not enough to threaten the stability of the bridge. Every material, every bolt, every plate was selected with one goal in mind: to create a structure capable of surviving decades of storms, temperature changes, and the constant weight of traffic. This minute marks a turning point, the moment when the bridge stops being just a construction site and becomes a masterpiece of modern engineering. The foundations of the bridge extend deep into the earth, in some places more than 40 meters down, until they reach layers of solid rock that have remained unchanged for millions of years. This depth is essential, because a suspension bridge of this size must withstand forces far greater than its own weight: wind, temperature shifts, earthquakes, and the constant load of traffic. Engineers had to ensure that the towers would remain stable even during a magnitude 8 earthquake. To achieve this, each tower was reinforced with an internal steel core that acts like a shock absorber. During strong ground movement, the structure can flex slightly, just enough to release energy, and then return to its original position without damage. The foundations themselves were shaped to guide the wind rather than resist it. Every edge, every curve, every angle was calculated to reduce turbulence. Because at this scale, wind is not just a factor, it is one of the greatest threats a bridge can face. Minute by minute, the invisible part of the structure becomes clear. The true strength of the bridge lies not only in its towers and cables, but in the deep, silent foundations that anchor it to the earth. To ensure the bridge could withstand even the most extreme conditions, engineers turned their attention to one of its greatest enemies, the wind. At this scale, wind is not just a natural force, it is a constant threat capable of twisting steel, shaking cables, and destabilizing the entire structure. Before construction began, detailed models of the bridge were tested in massive wind tunnels. Not only small prototypes, but full-size sections of the roadway were exposed to hurricane-level gusts. These tests revealed how the deck would behave under different wind angles, speeds, and turbulence patterns. The roadway was then shaped with a special aerodynamic profile designed to prevent dangerous oscillations. Lessons from past failures, like the infamous Tacoma Narrows collapse, guided every curve and contour. The deck does not fight the wind, it works with it, allowing controlled movement that dissipates energy instead of resisting it. Throughout the entire structure, thousands of sensors were installed, measuring wind speed, detecting vibrations, monitoring cable tension, tracking temperature changes, and recording even the smallest structural movements. All data flows into a central monitoring system that operates around the clock. If anything unusual occurs, engineers can react immediately, long before a problem becomes visible. Minute by minute, the bridge proves that true strength is not rigidity, but the ability to adapt to the forces of nature. With every test, every measurement, and every reinforcement, the engineers' confidence grew. The bridge was not only enormous, it was safe. It was stable. It was ready to withstand the forces of nature. As the final tasks were completed, a sight emerged that the world had never seen before: a suspension bridge longer, taller, and more resilient than any structure built before it. The cables were perfectly tensioned, the roadway fully connected, and the foundations anchored deep into the rock like the roots of an ancient tree. Sensors confirmed that every movement, every load, and every gust of wind remained within the calculated limits. From a distance, the bridge now appeared as a floating arc of steel effortlessly spanning the gorge. Yet behind this elegance lay an engineering achievement made possible only through precision, courage, and years of planning. Minute by minute, it became clear, this structure was not just a record, it was a milestone of modern engineering. Thank you for joining us on this journey. Together, we explored the creation of the largest suspension bridge ever built in China, a structure that pushes the limits of engineering and stands as a symbol of human ambition and innovation. If you enjoyed this film and would like to see more documentaries about extraordinary engineering projects from around the world, we would truly appreciate your support. Feel free to subscribe, leave a like, and activate the notification bell. Your engagement helps us bring more stories like this to life. We'll see you in the next film.